now doing experiment 3, which is steam distillation. And this is the macro kit that you will be using. So in this kit, you will have, so actually we label it with a number, and then I assign this to a student. They kind of check it out. So there's this is the round bottom flask, another round bottom flask, round bottom flasks, and then separatory funnel, and then these are condensers. So condensers, and these are adapters, and then distillation heads. Okay, so similar to the micro kit, but this is now bigger. These glasswares are bigger, and they're also more expensive because these are glass joints. Okay, so this is the macro kit that we're going to be using for this experiment. So I will now assemble the setup. So I took a sand bath, sandless bath, no sand, I did not put sand. And then I attach it to the transformer, okay? And then I'm gonna set it to 120 volts when I'm ready. And then again, this is attached to the power. I will take out from the macro kit the round bottom flask, okay? 3-neck round bottom flask. And I will clamp it. So basically I will put it setting on the sand bath because we will heat this up. And then I clamp. So I press this so that I don't have a lot of pressure against it. And then I clamp it. Okay? And I have a jack, and I have the I have the stand, I have another stand, and I have another jack. Okay? And then I'm gonna take several adapters in here. So this piece, okay? And then I'm gonna put these like that in the middle, and I'm also going to put this piece over here. And then I have a adapter. So I took a thermometer. So I have a thermometer. I actually took thermometer which goes up to 110. I don't have to take the thermometer that goes up to 250. And then gently, and also because this is glass and then this is rubber, one technique is you moisten this with water so it slides much better, okay? And there's not a lot of restriction, okay? So it slides better. And then I'm going to put it over here. So it's a little bit long, so I'm gonna push it up, okay? So that the bulb is just slightly below this side arm, okay? But I will take it out because I don't want to break the thermometer, and I will attach it later. I just want to measure the height that it goes down in this arm, right? Now, the next thing is from the macro kit, there are 2 condensers. I took one, so it doesn't matter which one, either one you can use. So I took 2 rubber tubings. So as you can see, there's a jacket, okay? So I'm gonna attach 2, and then so the same technique. This is glass and this is rubber. You moisten this with water so that it slides much faster and easier than if it's very dry. So this is the bottom. So it's gonna go like this. So this is the bottom. So this one here is going to be attached to the water outlet. Okay, so I moisten it again, water. All right, and then I'm gonna clamp it here. Okay, so I'm gonna use this clamp so that it's stable. Okay, so there's like a smaller diameter, the other one is wider, so the smaller one goes in here because this is smaller and this is larger. So I clamp it. Okay, that's the blue clamp. Okay, and then so that it doesn't fall all over me, I want this clamp. Okay, so again, to clamp, you press this one and then you screw gently. Okay, then it's stable. So that's the setup. Okay, so this is the condenser. So when I have it attached to the water over here, so this is the lower end, and then I have this as the outlet. So it's going to go to the drain. The upper end is going to go, the upper tubing, this part here is going to go to the drain. So the water going in, okay, over here, and it's going to go out here. So I'm going to have these slowly, the water coming out, okay, water inlet. So watch this one here, okay, all right. So I'm going to push the water if I have it on, okay, okay, it's not going inside but it's outside, it's an outer jacket. So now it's going down the drain over here. Okay, so the water is constantly cooling this part, so this part is always cold, and it's gonna push by pressure going out. Okay, all right, okay, so I can adjust a little bit more. So I don't really want this in full blast, so that's enough. Okay, and this should be to the drain. This is basically just water, tap water. All right, it goes down here, the drain. So the sample that we're going to be using for the experiment is the whole. So I will now grind the cloves in here. So this is the mortar vessel, and then I'm gonna grind it, not pulverize it, but just grind it slightly so I can expose the oil during distillation. So I'm just gonna do like this, okay? This is now the cloves when I grind it, and take note that I'm not pulverizing it. If you pulverize it too much, if you grind it so much, it will cause a lot of frothing when you are distilling. So just take note that this is the original sample, okay, and this is now after grinding. All right, so I'm gonna finish grinding, and then I will also now add this sample. So I put a powder funnel. This is plastic, and then I'm going to add on the side. So I already have actually added inside some sample. Okay, so, and then I'm gonna add this, and I'm gonna add the remainder. Okay, and then after I added everything, the 7 grams, I'm going to add now water in here. So I measured 100, so I'm gonna add actually 150 ml water. So I added water to the ground cloves, and then we're gonna boil this, and then it's gonna distill up, and then the vapor, so liquid to vapor, vapor to liquid. I started heating already, and again I mentioned that the water is always on all the time, so I still have it going through my condenser, and then I attach another adapter with a clip, and then I now have the receiver. It's a 125 e-flask inside, and I have a beaker. I'm going to put, once it starts to boil, I'm going to put ice water in here to chill this distillate. So the distillate is gonna come out here. And then, so right now, because there's nothing yet distilling, so I can see the sweat already. So this one is the sep funnel. I put 75 ml of water, distilled water, because I will actually collect 75 ml of the distillate and I want this one to be always wet, not dry. So I put also 75 ml of the water that I want to replace once this starts to distill and come out in here. So nothing is going up here yet. So the temperature right now is basically room temperature is about 25. Okay, so about 25 degrees C right now. So for this experiment, we will not be reading the temperature every 2 or 3 drops. We just read it when we collect the distillate. So there's only one reading that we're gonna be measuring. And now again, the sand bath is attached to the transformer. So never attach the sand bath directly to the power. So this is regulated. This one is attached to the power, and I set it for now to 60. I might adjust these. It's about 60, and again 120 volts, because each sand bath is designed, almost the same, but almost similar, but not the same. So it might heat up a little bit, slightly less or a bit more. So I don't know. So if it's too slow, I'm going to increase the setting for the transformer. So I put actually a cover in here, okay? So it's closed because I don't want the vapor to come out, okay? This is also closed for now. The stopcock is closed. And this is closed, but it's open in here. So the entire system is not entirely closed. Otherwise, if I close everything and I'm heating it up, it's gonna like explode, right? But because this is open, when I heat it, the vapor is gonna come out. It's gonna come out. The vapor will not accumulate in my system. I still have an outlet for the gas to escape in this part here. So if I lower the jack, this is open. Okay, so the water or the distillate containing mixture of oil and water is gonna come out in here. So actually, if this experiment is face to face, you can smell the aroma or the scent of the cloves. And it's actually, you put this in ham or you put it maybe in a turkey. So it has a really nice smell when you're distilling. So the lab smells really nice. And it smells like home, it smells like kitchen. Okay? But I guess I cannot videotape the smell. Okay, so now I'm gonna raise this again. And again, when I start to see that it's going to, it's boiling, I'm gonna put ice water in here. After about almost 10 minutes of boiling, the temperature now is increasing, so it's almost 94. And then as you can see below, you see a lot of, it's boiling, the solution mixture is boiling, and then you can see all the vapor coming up in here. So it's now touching the bulb, so the temperature is now being detected with the thermometer when the vapor goes up. So now I don't see any distillate yet, so it's gonna come out here. So I see the sweat in here, right? And actually this is hot, okay? So remember that because we added water, the boiling the temperature of this mixture or this vapor is almost 100. So pretty soon we're gonna see it collecting here. So I already put ice water. I'm gonna chill the distillate because I want the vapor to actually be cold, and I can collect the liquid. So I don't want it to be vaporizing. That's why I chill it. So I'm gonna add more ice water in here. Okay. All right. So now, actually, if you look back in here, so the temperature is about 99 degrees C. So it's starting to distill over here. So you can see here. So when you're doing this, oh, I got the first drop. Okay. So it went through fast. Okay. So actually, if I show you here. So I got the first drop in here. Okay, so it's milky, it's not clear. So I have here, so you can see the distillate here is milky. So I'm gonna raise this so that it's under that ice water. Okay, so as a note, so I see again that drop coming out here. You can see there's a drop. Okay, so I'm gonna collect 75. So see, okay, see the drop coming out, running from here to here. So again, this is a condenser, so it condenses. This is cold, and it's condensing the vapor, so that when it touches these, it's gonna be a liquid. So it's not vaporizing. Otherwise, it's gonna come out. It's vapor. Okay, so again, I'm collecting it. The vapor now becomes a liquid, and so nothing is, so it's not open. So I have the vapor trapped, so that when it distills in here, I'm collecting the distillate in this flask. Okay, so when the level of this goes down, approximately, I'm going to add. So I have like maybe 5 drops. So not yet. So I'm gonna replace whatever is lost in here, so that I'm not drying this mixture. And as a note, when you're using glassware like this, okay, make sure that you don't see any star, okay, especially the round bottom flask. Any star, you know, because that will break, especially when you're heating something, it breaks. So any star-like appearance of the glassware, especially at the bottom, don't use it because it will break. Okay. So technically, when we're doing this in the lab, you're gonna be paired up. So each student will have a partner doing the experiment, and one student should be watching these, and then you should also be, the other partner should be thinking about what the next steps are, okay? While another student is watching that distillation, I can set up the extraction. I have the stand, and then I have a ring, so that I prepare myself for the next step. So basically, that's how you do it. When there's like a lag time, and one person is watching the setup, so don't ever leave this, because you don't know if how you're heating is too fast or too slow. So don't ever leave your setup, especially when you're boiling something. So the temperature right now is almost 100, and as you can see here, it's still distilling. And then I also replaced some water, so I'm gonna add. When I add this water, the temperature is gonna go down. So I replaced some of the water that actually came out. So you can see that the temperature slightly went down, because it kind of delayed or stopped distilling because I added cold water. So now it's still distilling, and I'm going to collect about 75 ml of the milky distillate. So the 75 mark is around here. So we're almost done, maybe another 10 minutes or so. So that's 75 mark on the flask. All right. Okay, so that's the 75 mark, you can see here. Okay, and you can see still the drops over here. I'm gonna raise this to chill it. Okay, and again, I still have the water going in the condenser. Okay, so it's still cold, and so we're done we're almost done with this distillation, and so I replaced the water that evaporated. So really the temperature did not go beyond 100. It's almost touching the 100 mark. And I added all the water from the sub funnel, and I already collected 75 ml, and I will now stop the distillation. So first I'm going to turn this off. Okay, off. So I turned that off, and then I will leave the setup, and I will take this out once I don't see any more dripping, any more distillate dripping. And I will slightly lower these, but just be careful that I don't, it's clamped, but I don't want that it falls on it and I break it. So I lifted it. I actually lower down the jack a little bit so it's not touching the bottom of the sand bath. So remember that I have it touching to the bottom of the sand bath. Okay, so because I want to now stop the distillation because I already collected 75 ml. So this is now the distillate here. Okay, so it's 75 ml right now. So this is done. It took me from the time I set it up about 1 hour until I got the 75 ml of distillate. So it's milky white. This part is the extraction part of the experiment. So I have now this time the distillate, right? So I have about 75 ml, and this is cloudy, milky, and the oil is in the water. So this is a mixture of oil and water, so it's milky white, and this is now the sub funnel. Okay. So we're going to do what is called liquid extraction. So we want to extract the oil from the distillate because remember, this is actually oil and water. And I'm going to pour this into the sub funnel. Okay. And then I'm going to add 10 ml of the DCM. So this is dichloromethane or methylene chloride. Is an organic solvent. Dichloromethane or methylene chloride, DCM. So we abbreviate that as DCM, dichloromethane. And then I measured about 10 ml. Okay, and then I'm gonna add it here. Okay. So now take note that I have 2 layers. Now DCM has chlorine in it. So solvents with chlorine will be heavy. The density is higher. So it went down here. My milky white distillate is the upper layer. So I have a lower layer, upper layer. Lower layer, upper layer. So I have 2 layers. So I'm now going to do, what I'm going to do is extract using the DCM because my oil is in here with the water. So I'm going to do extraction so that my oil goes into the lower layer. So now what I'm going to do is I take out the funnel, and then I will put a lid in here. Now the DCM has is volatile. It has low boiling point than the water and the oil. So if I shake this, because now it's enclosed, right? It's closed. If I shake it too much, it's gonna come out. It will try to come out and it'll try to pop out because of the pressure that is built up. So the way we do it is I will take this out. Okay, I'm under the hood, and I will invert, and I will release the pressure. So you heard that pressure, right? It's actually, you can see that it came out some bubbles. So this is open, I close it. Okay, and I'm holding these with my finger. Okay, and I invert again. The other way to do that is to just release it here. Okay, so now still it did not mix. It's like salad dressing, oil and water mixture. So again, I invert, and then you constantly release the pressure so that when you're shaking, it doesn't come out and then it kind of goes to your hand. So I'm gonna shake it like this slowly. Okay, I can release it here, do again, or I can release it here while I'm holding it with my finger. Okay, so you heard that pop, right? Because that's the pressure built up from the more volatile liquid, which is DCM. Because I'm shaking it, there's a pressure that is being built up. I close again, shake, release, until that pressure, once it's equilibrated, you have now the pressure of the DCM, then it will not pop up as much. Okay? Right? Okay, so I will do that a couple of times. All right? But I don't want to shake it too vigorously, because sometimes when you do that, when you're doing liquid extraction, you want to be able to see the layer. If you're doing it so much, shaking so much, sometimes the layer you cannot distinguish, then you cannot separate. So I'm just doing like this. Okay? Okay? You see that the liquid actually is kind of trying to escape because of the pressure. You see it coming up. Okay? All right. Do again. So you can shake as much as you can, as long as you still can see the layer. Otherwise, if you don't see it, then everything is mixed up together. You cannot separate. Okay? So now I'm ready to separate. Okay? So again, the purpose for the DCM is to take the oil from the distillate. But as you can see, I don't really see any difference, right? The DCM is still clear, and then this top one is still milky. All right? So now I put it back in here. And I'm going to drain it here. So I'm gonna drain it in this container. Okay. So basically, I'm gonna do 2 extractions. The first one is 10 ml. I'm gonna do again 10 mils. It's like twice 10 mils. So there's a purpose for that. Instead of doing it 20 mils at a time, I do twice, but 10 mil each time. So now to be able to drain this, I take out the lid. Otherwise, it will not come down because there's no pressure pushing it down. So I have to take this out so that the air pressure will push it down and I can drain the lower layer. Okay? So now I drain it. So I open the stopcock parallel to this opening. Okay? So until that white thing, boom. Okay. So if I have droplets of distillate that came down, that's okay, because we will be able to get rid of it anyway later on. Okay. So now I do one more time. So I'm gonna measure again 10 mils of the DCM. So 10 mils, I'm just gonna pour it, or you can measure using the dropper, it's okay. The pipette, okay? So 10 mils, all right? And then I'm gonna use this one, the funnel, because I don't wanna spill it. And then again, I add. So I repeat the process, okay? So every time you add a volatile solvent, put the lid and then do the same thing. You're gonna invert first and release the pressure, okay? And then shake. So again, you can also release it from the top over here, okay? All right. So I'm holding this lid, because otherwise if I let go, it's gonna go out, right? So now I release it here. Okay, you can see it, the pressure coming up, and then do again, right? You heard it pop. Okay. So I went under the hood because I don't want to smell the solvent, which is DCM. And if we're doing it face-to-face in class, there's also like bench hood. All right. So now I'm gonna separate again. I'm gonna combine it with the previous extract. So this is now my extract, the DCM extract with the oil. Okay. So I'm gonna do the same thing here. Again, I took out the lid. So I'm just draining the bottom layer, which is the organic layer. Okay? So I close it once I see that the milky distillate touches the bottom of the stopcock, or the top portion of the stopcock. So this is now my distillate. So as you can see, I have like droplets of distillate, which is the water. Okay? So, and also, so this now is a mixture of a little bit of the distillate, all right? It's actually, you can see like it's floating. And then I have the DCM, it's clear. And then I don't really see the oil. So we will know if we were able to extract it when we do the IR later on, okay? So this one, I want to get rid of this blob, okay? So one way to do that is, to, I can put it back, okay? But the thing is, because I'm not done with the experiment, I don't want to get rid of this yet, okay? In case I don't have enough oil. So for the IR, so I'm thinking ahead, all right? The IR, we don't want any water in the IR. So we want to get rid of that blob because it has water. So it's like, again, it's still like a salad dressing kind of thing, right? It's floating. So there's a blob, right? Which is the distillate. So what I'm gonna do is I'm going to put sodium sulfate. So sodium sulfate anhydrous is a drying agent. There are several drying agents that you can use, but one is sodium sulfate. So this is a salt. So we're going to scoop using the scoopula over here. And then I'm going to cover the bottom, okay? So I'll cover the bottom. So I don't spill it, I'm going to use this one. Or you can basically just scoop it like this. But, I don't want to spill it, so I'm just going to go like that, okay? Okay, I scoop. I'm not measuring because I don't really need to know how much I'm putting, because I basically just want to cover the bottom. So I want to cover the bottom, So when I swirl it, you see that the blob started to disappear. Okay, so the blob should be absorbed into the sodium sulfate because remember it's actually aqueous, right? So I can put more. I can put more of the sodium sulfate, and I can actually just scoop it like that. Okay, and then again I swirl it. So I cover the bottom. So this should clear up. I want the liquid portion to be clear with the blob gone. And then I can let it sit for like a minute or two to let it absorb. Okay, so I let it sit here. All right, and then what we're gonna be doing while we're waiting for this to sit so that the blob gets absorbed into the sodium sulfate, in the case that it cleared up, actually I don't see the blob floating. It's actually now in the sodium sulfate. The sodium sulfate anhydrous absorb that water. Okay, so I can swirl it some more so it's clear, the liquid. What we want is the liquid to be clear. Okay, I will let it sit. Okay, now for the time being, I'm going to tear the flask because we want the weight of the oil. I zeroed the balance. Okay, I'm gonna so write this down because this is the data. So this is now the weight of the flask, which is 38.729. Again, it's 38.729 grams. Write this down, please, in your notebook. We need this data. This is now the flask that we weighed. So we had the weight of this flask, and we're going to transfer now the liquid portion of this solution that we're drying. So remember that this is the bottom is sodium sulfate, okay? And we don't want it. And there are different ways to do this. One way is to just decant. So decant is pouring it. But sometimes if you spill the sodium sulfate, you're going to repeat it. So another way to do that, to make sure that you don't transfer the sodium sulfate, is to get a glass wool. So this is a glass wool. It's actually made of glass. Okay, so be careful when you're using this because you might get a cut. So I took out a little bit. Okay, and then you kind of you're gonna make a plug. So you're gonna make a plug, and then I put it here. Okay, and then I push it with a boiling stick so that I make a plug. Okay, so that's my filtration apparatus, and then I'm gonna pour it. Okay, then I know that the sodium sulfate will not go through in case it goes in. Okay, typically it should stay, but I showed you one way to make a filtration. Okay, and then because I want to make sure that I took out all the oil, I can also rinse this again with DCM, like maybe 2 mils. Okay, all right, and then I rinse it to make sure that everything is transferred, and then do again. Okay, so some sodium sulfate went in, but it's protected because I had the plug. Okay, so now I take this out, and then I'm going to put a boiling stick, and we're now ready to heat this up. So remember, this is the DCM, no sodium sulfate, and we had the DCM plus the oil and no more water. So we don't know that we actually have the oil in here, but we know that we have DCM because I added DCM. So the DCM has a low boiling point, and the oil has a higher boiling point. So I'm gonna boil it. So I'm gonna set these to less than 100 because the boiling point of DCM is low. And actually this scale doesn't really translate to the temperature. It's just the way it's gonna heat this up. So I'm gonna set it to in between 30 and 100. Okay, I can adjust it later when I see that it's starting to boil so fast. Okay, but I don't want to set it, so I set it to about, I think it's about maybe 50 or so. Okay, if it's boiling so fast, I can lower it down because it takes a while for that to, you know, crank up the heat. So you will see that it's gonna boil, and I have the boiling stick to control the heating. And at the end, we should just see the oil. And I don't want that the oil evaporates. Okay? So I'm gonna watch for this so remember, I added 20 mils of the DCM. So right now, it's about 20 mils. So this is the level of the solvent. So that means that the amount of the oil is actually very small. Okay, so we're gonna leave it and then watch. It's actually starting to get hot. Okay, so I can feel it already when I touch it. Okay, so I see that it's already starting to kind of evaporate. I see some moisture going up in here. So I set it to, I think, around 50. Okay, so again, I can lower it if it's too fast. The bubbling now significantly decreased, and you can see that there's, like, you know, liquid at the bottom. And now it's ready to be weighed, but I'm gonna cool it to room temperature, and then we're gonna weigh this. This is our sample, so I allowed it to cool to room temperature for about 5 minutes, and it's not warm. Okay, and then we're going now to weigh the sample. So the weight right now is 39.608 grams, and that's gonna be the flask and the oil. So you're gonna subtract the weight of the flask that we had earlier. Okay, so after the distillation setup, I disassembled it, and after I cooled it, and then now this is the remainder of that. This is the residue of the cloves, and then it did not create a lot of frothing. Otherwise, the bubbles will come up here, and then it will go up the distillation head. So I don't want that. So now I'm going to decant the water. This is basically just water. So it's like, you know, food at home water. And then we did not really add anything except the cloves, right? So I'm just going to decant it, and then I will put it in the garbage. IR spectroscopy. So this is the last part of this experiment, is to show you how to run an IR. So IR is infrared spectroscopy. This is one of the spectroscopic techniques for organic chemistry, and we're gonna use this also in OChem 2. So this is an accessory. And as a note, I actually have all the instructions posted at the back. Okay, it's a very easy instrument to use, and again, it's powered by the software, by the computer. But this is where you put the sample. So the first thing you do is we're gonna run the background. So the background is just air, and typically it would pick up CO2 in the air, in the atmosphere. And then when you run your sample, it subtracts it, and then what you're seeing is just going to be the IR spectrum of your sample. Typically you have it this screen, right? And then the software is called Omnic. So you double click on it, and it will show these, and you just do OK. Okay, so that's the software. It's called Omnic. So when I double click on it, this shows up, and you can just do full view. So the few icons that you need is actually, the first one is this part here, collect background. So I'm hovering the mouse on it, and then collect sample. Okay, and then so make sure that you have this machine. It's called ATR, attenuated total reflectance. This is where you put the sample. So you can run liquid and solid in this machine. So we're gonna do for this experiment a liquid. So the first thing you do is you have it, it's like that. Okay, I'm doing it counterclockwise and there's nothing. So you're gonna screw it down clockwise, and then you're gonna hear that click. Okay, and then it's now touching the plate. So as you can see, if I put it up, you can see that there's like a light, a red light. That's the infrared. Okay, so that's where you put the sample. There's a hole. Okay, and then I screw it down. All right, so basically I'm going to scan just the air. So now I'm gonna click on the collect background, and then I do okay. All right, I do okay, and then it's gonna start collecting. So you see it's collecting up to 8 scans. Okay, so this one will fill up black, and then you see the scan of the air. Okay, so I just say, typically I will not use this because I don't really need the background, because actually this one is your CO2. So if you don't blanket, so this is like the background, you're running the background. If you don't blanket, you're gonna see a big, large absorption band around this region. So it's from 4,000 to about less than 1,000, but for our purposes, we're just gonna be looking at from 4,000 to about 1,250 or so. Okay, so now in this little window, I'm just gonna exit no, because I don't really need it. Okay, no, and now it's blank again. Now we're ready to put the sample. So this thing here is called ATR pressure tower. So I turn it counterclockwise, so you can see that it's actually going up, and this is the sample holder. So I can put it left or right. Okay, so I want it out of my way, and now I'm going to introduce the sample. So remember, our sample is oil, so I'm gonna put a little bit, like a drop. Okay, so I'm gonna put a drop into that hole where you see a red light. Okay, and then quickly I press it down, the ATR pressure tower, and you heard that click. And now I'm going to run. Now I'm gonna click collect sample. Collect sample. Okay, and then I just say okay, and then sample okay, and then it's gonna collect up to 8 scans. Now I have the sample. Okay, so I'm gonna do add to window, and this is my sample. So I'm going to label the peaks. So I put the cursor or the mouse over here. So I'm gonna put it here. So actually we're gonna do find peaks, and I put it up. Okay, and I label all the absorption bands, and I just do replace. Okay, replace, and then that's my sample. So I want also full scale, so I can see everything. So I labeled everything. Okay, and oh, actually I want to label this one. So you can also manually label the peaks by clicking the T at the bottom, and then now I do this, and then I have the absorption band. Okay, and then I can also label that one, but I can pull it down so it's not overlapping with this. All right, and then the same thing for that one, I can label it like that. So, and then I have, I think, everything here. and those are our absorption bands. And as you can see, I don't see any of the CO2 in here. Okay, so I'm gonna print it either here or I file print. Okay, it's now gonna come out over here. So print. Okay, so I will give you guys data. So this is our data. And actually, I have a sample which is so this is eugenol. Okay, and if you're changing sample, say you want to run another sample, okay, so this is how you clean up so that it's ready for the next person, for the next user. So every time you run, when you're done, clean up, please. So that's just the protocol. And how do you do that? So you are going to again raise this ATR pressure tower and slowly put it to the side, and you will get a little bit of this cotton. So this is a cotton, and take out, okay, and then you will moisten this with isopropanol to clean up what you put. So put a little bit in that cotton and then wipe it, okay, and then I'm also going to wipe that ATR that came into contact with my sample. Okay, so I'm going to do one more. Okay, right, and I'm gonna aerate this for like 5-10 minutes because I don't want, if I put my sample, it has isopropanol, it will evaporate fast, but to make sure that I don't have isopropanol, I'm gonna let it dry for 5-10 minutes before I put the next sample. So I'm running an IR of a reference. Okay, this is actually an old sample, but we'll see. So this is eugenol clove oil, and again the same thing. So just a drop of the sample. Okay, and then I'm gonna do the same. Okay, and then I'm going to clear this because I don't need that. So I'm gonna do clear. So I will click on the clear here, clear, and then that should clean it. And then I'm gonna do now collect sample again. Click, click. Now it's gonna collect. So take note that I did not do a background because it's just like 5 minutes ago. This is now the IR spectrum of the eugenol reference sample. Even though it's old, it's still showing the peaks, and I already labeled everything here. So I'm gonna print it out now. So print, okay, print, and that's it. And to clean up, I showed you already how to clean it up. You're going to rinse it or clean it with isopropanol with the cotton, and then let it evaporate so that the next person or the next user will be able to use it right away after drying the 2-propanol.